Welcome to channel Forensic 360. Today's topic is forensic entomology, a scientific discipline that helps solve crimes by studying insect colonization on decomposing remains. Let's start. Forensic entomology, solving crimes with insects. From the tiniest bugs to the most complex investigations, forensic entomology unravels the mysteries of the past. Forensic entomology is a vital branch of forensic science that uses insect activity to help solve criminal investigations. When a body decomposes, insects such as flies and beetles colonize the remains in predictable patterns. By studying their life cycles, forensic entomologists can estimate the time since death, determine if a body was moved, or even detect toxins present in the remains. This field bridges biology and criminology, turning tiny bugs into crucial witnesses. Whether solving homicides, uncovering environmental crimes, or assisting in archaeological research, forensic entomology provides key insights into mysteries hidden in the past. Now let's see what is forensic entomology. Definition: forensic entomology applies the study of insects and arthropods to aid legal investigations. Subfields: medico-legal entomology focuses on crime scenes, while urban and stored product entomology involve pests and food contamination. Forensic entomology is the application of insect and arthropod studies to legal investigations, providing valuable insights in various cases. Medico-legal entomology plays a crucial role in crime scene investigations, particularly in determining the post-mortem interval, PMI, by analyzing insect activity on decomposing remains. In contrast, urban entomology deals with pest infestations in homes and businesses, often linked to legal disputes over negligence or property damage. Stored product entomology focuses on insect contamination in food and agricultural products, assisting in cases of food safety violations. Together, these branches showcase the diverse impact of forensic entomology in both criminal and civil investigations. Now move to key applications. First one is post-mortem interval, PMI, estimation. Second is toxicology, identifying toxins in the body. Third is locating and tracing the movement of corpses. Last is abuse and neglect cases. Forensic entomology plays a crucial role in various aspects of legal investigations. One of its primary applications is post-mortem interval, PMI, estimation, where experts analyze insect colonization on a body to determine the time since death. Additionally, forensic entomologists contribute to toxicology by identifying toxins or drugs present in a body through insect tissue analysis, especially when human remains are too decomposed for standard toxicology tests. They also assist in locating and tracing the movement of corpses, as insect species vary by region, helping investigators determine if a body was moved post-mortem. Moreover, forensic entomology aids in abuse and neglect cases, detecting infestations on living victims such as neglected children or elderly individuals, which can provide evidence of prolonged mistreatment. Estimating time since death, PMI. Blowflies. These insects are the first responders, arriving within minutes of death. Larval stages. Analyzing the development stages of fly larvae reveals a precise time frame for the death. Succession. Insects colonize a body in a predictable order, leaving a trail of evidence for forensic entomologists. Blowflies are nature's first responders, arriving at a body within minutes of death to lay their eggs. Their presence is crucial in forensic investigations, as their predictable life cycle provides key insights into the post-mortem interval, PMI. Larval stages play a vital role in PMI estimation. By examining the development of fly larvae from eggs to maggots and pupae, experts can determine how long a body has been exposed. Growth rates depend on species and environmental conditions, making precise analysis essential. Succession follows a structured pattern, where different insect species colonize the body at specific decomposition stages. This predictable sequence helps forensic entomologists establish a timeline, track environmental influences, and even detect if a body was relocated after death. Let's discuss about insects as toxin detectives. Analysis. Forensic entomologists use sophisticated techniques like GCMS to identify and quantify toxins present. Absorption. Larvae absorb drugs and poisons from decomposing tissue, acting as biological indicators. Analysis in forensic entomology involves advanced techniques such as gas chromatography, mass spectrometry, GCMS, to detect and quantify toxins in decomposing remains. Since traditional toxicology tests may be impossible on severely degraded bodies, forensic entomologists analyze insects that have fed on the tissues to uncover the presence of drugs, poisons, or other chemicals. Absorption plays a crucial role in this process. Fly larvae feeding on decomposing tissue absorb toxins and drugs present in the body, effectively becoming biological indicators of substance exposure. By examining these larvae, forensic experts can determine if the deceased was exposed to drugs or poisons before death, providing critical evidence in criminal investigations. Abuse and neglect cases. Insect activity in living victims can reveal signs of neglect and abuse. Myisis, the infestation of living tissue by fly larvae, is a telltale sign of prolonged neglect in children and elderly individuals. Forensic entomology in abuse and neglect cases. Forensic entomology is not limited to homicide investigations. It also plays a crucial role in identifying cases of abuse and neglect, especially involving vulnerable populations such as children, the elderly, and individuals with disabilities. Insects, particularly flies, are naturally attracted to open wounds, unclean environments, and decaying organic matter. When forensic entomologists find evidence of insect activity on a living victim, it strongly suggests prolonged neglect, unsanitary conditions, or untreated injuries. Myisis, a disturbing indicator of neglect. One of the most telling signs of severe neglect is myisis, a medical condition where fly larvae, maggots, infest living tissue. Flies lay eggs in open wounds, unclean skin folds, or areas with poor hygiene, leading to maggot infestation. Myisis is commonly observed in cases where individuals have been left without proper care for an extended period, such as in elderly abuse. Neglected seniors in nursing homes or private residences may suffer from untreated wounds, bed sores, or poor hygiene, allowing flies to lay eggs. Child neglect, children left in filthy environments, denied medical care, or suffering from untreated wounds may develop myisis, signaling long-term mistreatment. Disabled or immobilized individuals, people with limited mobility who are left unattended, can develop infestations due to lack of hygiene and wound care. How forensic entomologists help. Forensic experts analyze the type of insects present, their life cycle stage, and the severity of infestation to estimate how long the victim has been exposed to neglect. This can help determine the duration of abuse, identify responsible caregivers, and provide critical evidence in legal cases. Additionally, the presence of certain insect species can reveal environmental conditions, such as whether a person was left in a warm, unsanitary area or denied proper medical treatment. By documenting insect activity and its impact on living victims, forensic entomologists play a vital role in ensuring justice for those who suffer from abuse and neglect. Their findings can support legal action against perpetrators and improve standards of care for vulnerable individuals. Now let's see some limitations and controversies. Environmental factors. Temperature, humidity, and other environmental conditions impact insect behavior, affecting PMI calculations. Species variability. Different insect species have varying developmental rates, which can introduce error in PMI estimates. Standardization. Forensic entomology requires specialized expertise, and standardized procedures are still under development. Limitations and controversies in forensic entomology. While forensic entomology is a valuable tool in criminal investigations, it is not without its challenges. Several limitations and controversies affect the accuracy and reliability of insect-based evidence, particularly in estimating the postmortem interval, PMI, and interpreting forensic findings. Environmental factors. Insect activity is highly dependent on environmental conditions such as temperature, humidity, and exposure to light or wind. Since insect development speeds up in warm climates and slows down in cooler conditions, incorrect environmental assumptions can lead to errors in PMI calculations. Rain, drought, or urban settings can also alter insect colonization patterns, potentially affecting forensic conclusions. Species variability. Different insect species develop at varying rates, and their presence at a crime scene depends on regional and seasonal factors. Forensic entomologists must correctly identify species and understand their growth cycles to make accurate PMI estimations. However, if an uncommon species is present or if multiple species interact, it can introduce uncertainty in time-of-death estimates. Standardization and expertise. Forensic entomology is a specialized field that requires expert knowledge of insect identification, life cycle analysis, and environmental interactions. However, standardized protocols for sample collection, preservation, and analysis are still evolving. This lack of universal guidelines can lead to inconsistencies in forensic reports, making it difficult for courts to rely on entomological evidence without expert testimony and validation. Despite these challenges, forensic entomology remains a powerful investigative tool. Ongoing research, improved methodologies, and better standardization efforts aim to enhance the accuracy and credibility of insect-based evidence in legal cases. Let's study some of the historical case studies. Yuan Dynasty, China. The first recorded use of flies to solve a murder dates back to the 13th century in China. Forensic entomology in the Yuan Dynasty, China. One of the earliest recorded cases of forensic entomology dates back to the 13th century Yuan Dynasty in China. The case was documented in The Washing Away of Wrongs, Shi Yuan Ji Lu, a forensic science manual written by Song Si, a Chinese judge and forensic expert. In this case, a murder had been committed with a sickle, but there were no witnesses. To identify the murderer, the investigator gathered all the villagers and had them lay their sickles on the ground. Although the murder weapon appeared clean to the human eye, flies were naturally attracted to the traces of blood left on the guilty person's sickle. This simple yet ingenious observation led to the identification and confession of the murderer. This historical case highlights the early understanding of insect behavior in forensic investigations and marks one of the first recorded uses of forensic entomology in solving crimes. Ruxton Case, 1935. Blowfly evidence played a crucial role in reconstructing the events of a brutal dismemberment case in England. The Ruxton Case, 1935. Blowfly evidence in forensic investigation. The Ruxton case is one of the most famous early examples of forensic entomology assisting in criminal investigations. In 1935, Dr. Buck Ruxton, a physician in England, brutally murdered and dismembered his wife, Isabella Ruxton, and their housemaid, Mary Rogerson. He attempted to conceal the crime by scattering the body parts across a remote area in Scotland. Forensic experts used multiple techniques to reassemble and identify the victims, but a key breakthrough came from blowfly larvae found on the remains. By analyzing the developmental stage of the maggots, forensic entomologists estimated the post-mortem interval, PMI, proving that the murders occurred while Ruxton still had an alibi. This evidence contradicted his claims and helped secure his conviction. The Ruxton case demonstrated the power of forensic entomology in time-of-death estimation, paving the way for its widespread acceptance in criminal investigations. Now let's come to modern tools and technology. DNA analysis. Forensic entomologists can use DNA analysis to identify insect species with unprecedented precision. Climate modeling. Software tools like ADH, accumulated degree hours, estimate insect development rates under varying environmental conditions. Database. Comprehensive databases document insect behavior, allowing forensic entomologists to compare regional patterns. Advancements in forensic entomology. DNA analysis. Forensic entomologists utilize DNA analysis to accurately identify insect species, especially when morphological identification is challenging. By extracting and sequencing DNA from insect samples, experts can differentiate closely related species with unprecedented precision, reducing errors in post-mortem interval, PMI, estimation. DNA analysis is also used to detect human DNA from insect gut contents, potentially linking insects to crime scenes or victims. Climate modeling. Environmental factors significantly affect insect development, making climate modeling essential in forensic entomology. Tools like accumulated degree hours, ADH, software estimate insect growth rates under varying temperature and humidity conditions. By integrating local climate data, forensic experts can refine PMI calculations, improving accuracy in different geographic locations and seasonal variations. Databases. Comprehensive forensic entomology databases document insect behavior, life cycles, and regional variations. These databases allow forensic scientists to compare findings with known insect colonization patterns, aiding in PMI estimation and case analysis. Access to extensive reference collections enhances the standardization of forensic entomology, making it a more reliable tool in legal investigations. These advancements continue to improve the accuracy, consistency, and credibility of forensic entomology in modern crime solving. Now move to conclusion and future directions. Forensic entomology plays a critical role in providing vital clues for solving crimes and unraveling the mysteries of the past. Conclusion and future directions. Forensic entomology is a powerful investigative tool that provides crucial insights into postmortem interval, PMI, estimation, toxicology, corpse movement, and cases of abuse or neglect. By studying insect colonization patterns and developmental stages, forensic experts help reconstruct crime scenes and uncover hidden evidence, making it an indispensable part of modern forensic science. Looking ahead, technological advancements such as DNA analysis, climate modeling, and AI-driven databases are set to enhance the accuracy and reliability of forensic entomology. Further research into regional insect behavior, climate impact, and standardization of forensic protocols will strengthen its application in legal investigations. As forensic entomology continues to evolve, its contributions to criminal justice, archaeology, and environmental forensics will expand, reinforcing its role in solving crimes and uncovering historical truths. That's all for today. Hit like, comment below, and share this video to your friends and family. Please do subscribe if you like to watch more videos like this. Thanks for watching. Goodbye.